Let's do a problem from your lab assignment, section 11.2. It says here, if the nth partial sum of a series, a sub n, as n goes from 1 to infinity, is equal to s sub n is equal to n minus 13 divided by n plus 13. This is the partial sum. Then find a sub n and find this sum. So it turns out that if we have the nth partial sum, then that nth partial sum will help us find the sum of the series if we take the limit of the nth partial sum as n goes off to infinity. And so that part we will take the limit, but they also want us to find a sub n. So let's see how they are going to ask us to go through it. Step 1, if the nth partial sum is given by s sub n is equal to this, then a sub 1 is equal to s sub 1. So that's exactly the first one. And the first one here is just the first term, and then we add up the first term. Well, there's only one term to add up, and that's when n is equal to 1. So it looks like I have 1 minus 13, I think that's a negative 12, and then divided by, and then we have a 1 plus 13, so that's a 14. I suppose we should reduce this to 6/7, but I think this is a case where the program is going to ask Mathematica and they'll just take whatever's equivalent. Alright, so in general, if we want the s sub nth term, we want, if we want the a sub nth term, we want the sum. So the sum, s sub n, will add up all the terms up to a sub n. Now, if we want to recover a sub n, then we essentially would add up all the terms up to, but not including a sub n. So by adding up all the terms up to n minus 1, we're really looking at the partial sum up to n minus 1. So it looks like we can leverage this formula that they gave us by putting n minus 1 in here and subtracting it from s sub n. So this is s sub n minus, this is s sub n minus 1. Okay, so what's that going to equal to? This is n minus 1 minus 13. So I think that's going to be n minus 14 divided by n minus 1 plus 13. So I think this is a plus 12 here. Okay, so now we have common denominators that we have to find because we're adding and subtracting. We're subtracting the s sub n term and the s sub n minus 1 term. So how are we going to do that? Looks like we need to do just a little bit of algebra. Let's see. We have n minus 13. Let's put parentheses around here, divided by n plus 13, and then we're subtracting n minus 14 divided by n plus 12. And so the common denominator is n plus 12 and n plus 13. So let's see, parentheses, and then n plus 12, and then divided by n plus 12. And then this one, we want to multiply top and bottom by n plus 13. All right, let's try to get that. So we FOIL out the numerator here. We're going to get, I'm going to do it on the side here. We're going to get n squared. We have negative 13 plus 12 minus n, and then 13 times 12. Ooh, what's 13 times 12? That would be 156, and it's a negative. So let's get rid of this. And now let's FOIL this out. We have n squared minus n again. And then minus, we have 13 times 14. That's 182. So when we add these two together, we're actually subtracting them. The n's squareds would cancel, the n's would cancel, and then I have negative 156 plus 182. And I think that's going to be 26. So, whoops. Let's type this over again. What was this again? This is n minus 14 divided by n plus 12. All right. So hopefully we did all the arithmetic there correctly. And then now, so that is the nth, that's the a sub n term right here. 26 divided by n plus 12 times n plus 13. The last step is to find the sum of the series. The sum of the series is really just the limit of the nth partial sum, and the limit of nth partial sum, if we multiply or divide both the top and the bottom by n, we will have a 1 minus 13 over n and a 1 plus 13 over n. And as n goes off to infinity, 13 over n will go to 0. So we just have 1 and 1. That's just going to give us a value of 1. Okay, I hope that helps. Good luck.